So to find the area under a curve, we increase the number of rectangles to infinity, and we get this equation. The limit as n goes to infinity, n is the number of rectangles. This is rectangles. Of the sum from I is equal to 1 to n of f of c delta x. Remember, this f of c is the height of the rectangle, and delta x is the width. And you add up all those rectangles, and we should get the actual area under a curve. So here's the very first question we're going to do. Are we excited, peoples? Yeah. I can feel the enthusiasm. Yeah, pretty much that's the correct answer.
This is our last unit.
No.
Why not?
But this is like basically calculus.
Yeah, because you are taking calculus.
No, like that's like.
calculus.
Okay, well make money.
This is calculus. You're not wrong. The other stuff was calculus too.
The limits isn't calculus.
The limits technically is not calculus. It's just something that's used in calculus. Yes. That is correct.
No wonder why I don't
Yeah, make money, guys. Whatever.
Don't just say it out in front of me because
What was limits?
Okay, you don't have to draw a picture. I like to draw a picture just because I'm such a brilliant artist.
You are. Whoa.
Thank you, Haley. All right, y is equal to x squared is a parabola centered at the origin. We're bounded by x equals 0, x equals 2, and the y-axis. So, x equals 0 is here, x equals 2 is there, and the x-axis, that's it. So this is the area that we're doing. We're finding this area. It is not a triangle because x squared is curved. Okay? Looks like a triangle, but it's not a triangle. Okay. I suggest using the right endpoint. Okay? It's a little more straightforward. But here we go. The area is equal to, whoops, I forgot the first thing, the limit. I is equal to 1 to n of okay. Delta x. Shh. First thing we got to do is find delta x. Yes. Delta x is b minus a over n. What's b? 2. A is 0, and n is n, so it's 2 over n. That's our delta x. That's the width of each rectangle that we will use. The c value is going to be a, which is, what's a? 0. So that's going to make the I disappear, right? 0 times anything. Plus delta x. Oh, I wrote it wrong. It's a plus I delta x. I know. Sorry, peoples. There, sorry. So it's I. And then delta x is 2 over n. So it's I times 2 over n. That's our c value. And I like 2i over n. That's better. There we go. All right. What is the c? C is where you are in here.
Oh no, I thought that I was.
Oh, okay. That's an I. Yeah, you're right. Sorry. Not very good with my. Okay. We plug them into this formula, f of c delta x. All right. Here we go. f of
How is that an
I'm moving my neck.
Sorry,
Thank you.
I'm blind.
Thank you.
Sorry, I'm blind.
There, is that better?
Oh.
Compared, because this is brutal.
He's struggling.
I'm so I
was looking like that.
so give me my chairs back, dude.
All right. Okay.
Oh, that's good stuff.
So, whatever's in brackets for the function goes where? And our function is x squared. So we get 2I over n all squared times 2 over n. What's 2I over n all squared? 4I squared over n squared. Into the function.
Oh, we put it into the phone. Okay, yeah.
I squared everything in the brackets. Oh my gosh.
Math.
Like, what if I do this, but I don't rewrite the signal? Over.
And then this has to actually do.
Oh, okay. I meant like, hold on.
All right. Then I can multiply the 2n in. I like writing this limit and the sigma.
People were lazy to write the whole word limit, so they made that abbreviation.
Yeah, saves you the I and the T. It's more efficient.
Yeah, but like that is not.
Yeah, why don't I just write L?
That is not.
It is efficient.
Well, you can just do a
Okay, so we have the sigma, the summation of 8I squared over n cubed as n goes to infinity. What can I pull out of the sigma? 8 over n cubed. You can pull it. Those are all constants, right? N is a constant because it's the number of rectangles, right? We keep increasing it because it is a limit, but essentially you can set it at anything you want. It is, yeah. It will. You got to treat it as a constant in this case. The I is changing because you're summing the rectangles, right? So you're summing the first 3 rectangles, or the first 4 rectangles, or the first 5 rectangles. Okay, what is the formula for the sum of I squared? Whoops. Over 6. Yes. So we get the limit bracket. The sum of I squared is n plus 1, 2n plus 1 over 6. Okay. I'm going to clean this up a little bit. I'm going to go that, turn into a 2, and that one goes away. Okay. I'm going to pull the 6 out, just so it looks like this. And I'm showing a lot of steps. You can, you don't have to show all these steps. Well, they're all being multiplied, right? So I canceled one of these, so it became n squared, and I just moved the 6 there and moved the n again. Now I'm going to FOIL the top. Leave the 8 over 6 out. That's me foiling the top. Is it? Plus 1. It is plus 1. Not 1 times 1 is not 2, people. Okay. You can pull constants out of limits, right? Okay, so the 8 over 6 is coming out. And single denominator, I'm going to rewrite it under each one. Again, I'm showing a lot of steps. You can do this in less steps. If you can do it in your head, that's fine. All right, I can simplify that. Of 2 plus 3 over n plus 1 over n squared.
Are we plugging infinity in here?
Now we're going to plug infinity in. What happens to everything that has an n in the denominator? Goes to 0. And you're left with 2. So it's 8 over 6 times 2, which is 8 over 3. That is the actual area under the curve of y is equal to x squared between 0 and 2. That is the exact answer. Is that not thrilling?
What was the question?
Look at that. Oh, it's long. I can't even fit the whole thing. There you go. I can almost fit the whole thing. It's asking for this little red area here. That area is 8 over 3.
Cool. Why do we need that?
Oh my gosh. That's a good question, actually. You'll find out in a bit. All right. I'm going to ask you to do one question right now. Do we think we can reproduce it? I have faith in you. Well, some of you. I'll let you figure out who that is. Page 64, number, you can do 45 or you can do 47. I'll let you choose.